This is the video for evaluating algebraic functions. At the end of this lesson, you will be able to evaluate a function for a given domain, which are your inputs, and determine the range of values, your outputs. So, what is an algebraic function? The definition that you need to write down is that it is an algebraic expression or rule that defines a function. This algebraic expression or rule tells you how to get from the input to the output. So we've seen function notation before, so we're going to take another look at it in this unit. Remember that when we have function notation with f of x, that x, or whatever variable is here in parentheses, really just stands for your input. Please make sure you are copying this down. Your output is represented by the entire notation f of x. Sometimes our output can also be represented as y. Therefore, f of x is equal to y. Both of these are your outputs. Your input is represented by the letter x. So in this example below, we have f of x equals 2x plus 3. This is our algebraic expression, or our rule, that defines f of x. In this example, x is our input. F of x will stand for our output, and our rule is 2x plus 3, which is going to tell us how we're going to get from each input to each output. So for example, if I chose to use 2 as my first input, that would mean that everywhere I saw the letter x, I would input the number 2. Now it's nice to think of functions as a function machine, or if you take a look at this picture down below, these are some characters from a Dr. Seuss story, and these are Sneetches walking into the machine, so they are the input, and they walk out as the Starbelly Sneetches, which is the output. So something goes in, and something else always comes out. In our function machine over here, if I input 2 using the rule, do you know what the output would be? If you guessed 7, you are correct. So today is all about evaluating expressions. To evaluate a function given an equation in the examples you're going to take a look at tonight, we always input the value of x, which we learned today is really our domain element, and then we evaluate or simplify the expression to find the y value. Our y value can be referred to in a couple different ways. It's really the output, which we saw can be represented by f of x, and it's also our element that comes from the range. Okay, so example 1 says let w equal the set of numbers of 0, 1, 2, 3, 4, and 5. The rule is to assign each x value in set w to this expression, 2 to the x power. So we can write this using function notation as w of x equals 2 to the x power. So a couple of examples below, we are going to find each of these. So to evaluate the function w, where 0 is the input, we are going to reuse our function notation, inputting 0 everywhere we see x. So in this example, we just need to do 2 to the 0 power. Do you remember what that equals? If you guessed 1, you are correct. Anything to the 0 power is 1. Down below over here, we have our magic function machine. Let's see if when 0 is our input, that we get 1 for our output. There it is. We are correct. Now let's input 1 for the function w. So w of 1, I will input 1 everywhere I see x. 2 to the first power. Let's see. When 1 is the input, out comes 2. So 2 is our output. Let's input 2 into the W. So 2 to the second power, or 2 times 2. If you said 4, you are correct. When 2 goes in, out comes 4. The next one, when 3 is the input, that means 2 to the third power. Remember, this really means 2 times 2 times 2. So when 3 is the input, the output is 8. 2 to the third power is 8. W to the fourth, or sorry, when 4 is the input for this function, 2 to the fourth power. Notice you should also start to see a pattern here. The output is going to be 16. And our function machine is correct. Out comes 16. And the last one, when 5 is your input. So 2 to the fifth power. If you guessed that it is, let's see, 32, you are correct. Good job. So we just evaluated this function W for each of the given inputs 0, 1, 2, 3, 4, and 5. What is the range of W? Do you remember from class today what range means? It really stands for our outputs. So according to our inputs, the range of W, we like to list it in a set and in order from least to greatest. So take a look at your outputs. These are all of them right here. So 1, 2, 4, 8, 16, and 32. And that is how you evaluate your functions and take a look at the domain and the range values. Let's try another example. In this example, find the value of each function where there are a couple different ways that we could read this inequality. We saw it in the last unit, where x is greater than or equal to 0 and where x is less than or equal to 5. And here's our function rule, our algebraic function, to evaluate each input. So since we are told to go from our x is 0 to our x is 5, we're going to stick to whole numbers. So we will include 0 and go to 1, 2, 3, 4, and 5. So first let's evaluate the function g when 0 is our input. So everywhere we see the letter x, we are going to input 0. So g of 0 means we will do 2 times 0, which is 0. So when 0 is the input, 0 is the output. Let's double check it with our magic function machine, and we got it. G of 1, when 1 is the input, so 2 times 1, 2 is your output. When 2 is your input, we will rewrite the function as 2 times 2. So the output is 4. G of 3 would give us 2 times 3. So when 3 is the input, 6 is our output. G of 4, so 2 times 4. When 4 is the input, we get 8 as the output. And the last one, 5. When 5 is the input, 10 is our output. So we've done this before, so this lesson is a little bit of a recap. Let's check all of our inputs using our function machine. So in goes 1, out comes 2. In goes 2, it follows the rule of 2 times x, and out comes 4. In goes 3, travels through, and out comes 6. 4 goes in, and out comes 8. And 5 goes through the machine, and out comes 10. So we got it. Underneath are a couple of U tries. You can cross out that T there next to the U, where you are going to find the value of each function for the specified input. Notice here you are given two different functions. One is f of x, so you must use this rule, 6x minus 3, when we're talking about function f. And then we have g of x, which the rule says 0.5 times 4 to the x power. You must use this rule anytime a function is referring to function g. So down below, please complete A, B, C, and D. I'd like you to write each of these doing one step at a time until you find your output. So please pause, and when you are done, play the video back to see how you did. So please pause at this time. The answers for the U-tries are now going to be revealed, so let's take a look. The ones on the left were all f of x. So when 0 was the input, -3 was the output. Be careful with these ones. Please make sure that you are doing your multiplication first, which in this case ends up on the left-hand side. Same thing down below, f of -10. You must multiply 6 times -10 first, and then you can subtract 3. So when -10 is the input to function f, -63 is the output. I'm hoping you did the same thing for g of x and followed your order of operations. So let's see. When 0 is the input, you must do your exponents first. So 4 to the 0 power becomes 1. So we are doing 0.5 times 1. So when 0 is the input, 0.5 is the output. Down below, when -1 is your input, remember that negative exponents work a little bit differently than you may think. They really just end up turning into fractions, where this gets sent to the denominator and the exponent becomes positive. So if you were to do 4 to the negative first power in your calculator, you would get 1 over 4, or 0.25. Then it's time to multiply 0.5 and 1/4, or a quarter. And so when -1 is the input, 0.125 is the output. We will continue evaluating expressions tomorrow in class in a couple of different other ways, in addition to what you saw in tonight's video. So please make sure if you come in with any questions that you may have, and this worksheet to class tomorrow. Thank you. Have a good night.